Hello friends, this video on redox reaction part 20 is brought to you by examfear.com. No more fear from exam. Now we'll discuss redox reaction in electrode process. See, we have seen this kind of reaction, zinc plus copper sulfate is equal to zinc plus copper. What if you want to divide this reaction? You see, what we do this experiment in an indirect manner, right? So the process of transfer of electron takes place in the indirect manner. Here is the direct transfer. So what we do is we set up something like this. Here we have zinc and zinc sulfate solution. Here we have copper and copper sulfate solution, right? So if you see in this case, this is copper, this is zinc, this is zinc sulfate or zinc nitrate you can take, and this is copper sulfate solution, blue color. Now if you see this reaction, if I see in this reaction my zinc becomes oxidized to zinc plus and copper is reduced to become copper. So what will happen in this case? In this case what will happen? Copper plus will become copper, right? So copper from the solution will join this plate, and here zinc from this plate will join this zinc sulfate solution, right? But after some time you will see the equilibrium will be reached because we'll have a lot of electrons here, right? Because both are separate now, right? Both are separate now because it will have plenty of electrons floating around, and this will have deficit of electrons, right? But the reaction will stop. So what we'll do if we add a salt bridge? See, salt bridge is something which can conduct electrons, because in this reaction what is happening is zinc is going to zinc, zinc is becoming zinc plus, and a lot of electrons are floating around here, right? Hope you understand this. A lot of electrons are floating around here. These electrons, I mean, there is a equilibrium region, the reaction won't happen now, and this has deficit of electrons, right? Because it consumed whatever electron it had, this deficit of electron, it is in need of electrons. So the reaction will stop. Now if somehow we can connect with a salt bridge is something which can help electron to transmit, right? So salt bridge is nothing but my NaCl I have used here. I can use anything else. Can I use metal here, copper? No. Why? If you use copper here, copper will react. If I use any other metal, reacting metal, it will react with the sulfate solution. Can I use anything else? Can I use any other metal? Yes. If we have gold, we can use gold because gold won't react, right? But that's very costly. So let's use NaCl, right? So NaCl, if you see, is Na plus and Cl minus. So it has electrons, actually free electrons, because it has this ionic compound. So it will help to pass electrons only. So electrons will flow in this direction, only electrons, not the sulfate solutions will flow, right? So in this case what will happen, the electron will come and join here. The moment it will get electrons, now this reaction will proceed where my copper needs electron to form copper sulfate, needs electron to form copper. So copper sulfate wants to become copper, but that needs electrons. So now with the salt bridge you'll get electron here, and now this electron will flow. And the moment there has to be a switch, right? I mean, if you stop the switch, it will stop. The moment you add on the switch, if you see, there is a full circuit now, right? So the electron will flow, it will come here, and again it will go like this. And that's how my battery works, the cells which we have, right? The voltaic cell works. You'll learn more about this in the next class. This is the concept saying that we are trying to have this redox reaction indirect way by having a salt bridge. So we have two different reactions here. So we have two different reactions here. In one reaction we have zinc getting zinc plus is giving electrons, and the second reaction we have is we had copper, it needed 2 electrons and it gives copper, right? So we divided this reaction into two different beakers, added a salt bridge in the circuit, so that makes sure that the electron which is required in common is flowing from the zinc sulfate bucket to the copper sulfate bucket, and then the whole reaction happens indirect way. And this concept is used to create batteries. We'll study more about this in the next class. And also if you see if you want to find the electrode potential of this, you see, right, some battery is 1 volt, some is 1.5 volt, some is 6 volt, some is 9 volt. How you get this? That is nothing but you add the electrode potential of both, right? So if this is less than x, this is y, the total electrode potential will be x plus y. One will be negative, one will be positive, but you are taking the opposite values, it will be x plus y. We'll take some examples on this. Before that, we'll see the chart. If you see, for iron, if it is getting reduced, right, it gives 2.87 electrons volt. Similarly, it goes down. For hydrogen, it is 0. And you see for zinc and copper, for copper, if you see, if it is giving 1 electron, it is 0.5 volt. If it is giving 2 electron, it is 0.3 volt. Correct. So this way, this is the chart which helps us in finding the electron volt for a given battery, which composed of let's suppose copper and zinc. So we can use this to find the electron volt for a given battery, right? We'll take some. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.